So, as you all know, Microsoft is our premier sponsor of Devcon 2, and Marley Gray, who's of blockchain engineering and the head of blockchain engineering, is here to both speak and give an introduction. And come on up, Marley. Give a hand for Marley Gray, please, Microsoft.
Thanks, Bing. Good morning. I think I should thank Roman for getting you guys wasted last night. So nobody's here this morning to see this. So the title of the speech this morning is a lap along Cryptlets, but what I really want to do is take a trip down memory lane, which was late July 2015 when Frontier was released, was when we officially started playing with Ethereum, such that we then launched with Ethereum together, with our partners Consensus, and started down the Ethereum blockchain as a service. So I always feel like the journey with, a lot of people point to Microsoft being an early adopter of Bitcoin. I think that was a sort of an experiment, our learning lesson for us to really embrace Ethereum. So I don't want to tell you what I had to go through to get the sponsorship for last year's Devcon. It was not pretty. This year's Devcon sponsorship was quite easy for me to do. It's a lot more money as well. But Ethereum, just to set the stage here for Microsoft's commitment here is, Ethereum is a first-class citizen, will continue to be a first-class citizen in our distributed ledger efforts at Microsoft. And it dominates our marketplace. And our customers are using it and asking us, and with that, we're gonna, I've got some things we're doing. I have a lot of partners in the room. I think almost everyone should be a partner. If you're not, please talk to your Microsoft representative. If you're a small startup, we have programs called BizSpark. I know a lot of you have taken advantage of that. Encourage you to do that. And we'll be talking some more about the other things later. But this morning I want to announce, proud to announce Bletchley version 1. So Bletchley is our code name for everything blockchain at Microsoft. And let me explain a little bit about what that is, and I'm going to walk you through what V1 means. But Bletchley, the architectural diagram over here is sort of the big picture, and you'll see Ethereum is quite prominent here. So our distributed ledger stack down at the bottom, this is what we call our distributed infrastructure, or Bletchley distributed infrastructure. We are shipping version 1, a consortium Ethereum private network starter. So you can go on Ethereum, any customer can, instead of just spinning up a single node or a single dev test lab, you can actually spin up a full consortium network, and I'll go through exactly what that means a little bit later on. You'll see this in the press. We released these announcements this morning. It's timed with this keynote. It's hard to time those things. I was up at 4 o'clock in the morning. Sid, I know you were up at like 3 working on this stuff. So we'll walk through this, but Ethereum is first class. We're going to walk through that. I'm going to first walk you through Cryptlets. So we introduced Cryptlets in June as a middleware approach for taking blockchains or bringing blockchains into the enterprise. All of our interest from our major enterprises are trying to figure out how consortiums will get together to take advantage of this distributed network promise. So Cryptlets is how we sort of get our head around this, and we'll look at it as a new tier. So those of you that have some gray hair will remember the pain we went through. We went from client server to 3-tiered architecture in the web, very similar to the pain that we're experiencing and the growing pains within distributed ledgers or blockchains. And so there's a lot of missing parts that enterprises want. They want things like, some people call them ILDs list, but it's essentially scalability, manageability, those types of things. So we identified these key things like identity, existing systems integration, key management, not just storing your keys, but managing the entire life cycle of your keys. It's a very difficult thing to do and do correctly. Security in depth, just a number of talks yesterday on security. I don't think we even had a topic on it last year, maybe one or two. But we're really getting to the point where people can start building solutions, industry-specific solutions. Financial services is the largest, but we're going to see them in healthcare, media, supply chain's huge, all over the place. So Cryptlets is our sort of our catch-all for delivering these capabilities in the cloud. So with the introduction of oracles, how do you get data injected or real-world data injected into a blockchain? Oracles came out, but it's more than just trusted data. It's how do you get trusted execution? We need a very flexible and malleable execution platform where you as an architect or a developer can make the right decisions based on what you're trying to do and have clean separation of concerns in your code, which is something in the enterprise is paid a lot of attention to. So things like doing things at specific times or specific intervals, doing things based on triggers. You can have market watches. You want to be able to also protect IP. If you have algorithms that you don't want those algorithms, in the clear on the blockchain. You want to protect those. You might want to scale an algorithm. You might want to have better performance than a blockchain can offer you. How do you achieve that while still getting the benefit of a distributed ledger? And then complex interactions. When we start getting into enterprise systems, you get into complex distributed transaction coordination, where you're not just updating the Ethereum network. You might be updating a CRM system, old host mainframe system, an Oracle database, a CRM system, and the Ethereum blockchain system in a single transaction. How do you do that? Well, we actually know how to do that, and that technology's been around since the turning part of the century because we had to go through those growing pains when we went to the web. So we want to be able to use those things and also use libraries like .NET and Java and pick your platform du jour. It's not just going to be about single language development. We need choice in platform and choice in language. So I'll put this in here. I'm not going to go through this chart. Some of the things that Cryptlets, I'll go through the key points. For this audience, getting secure data, and oracles have been around for some time. It's still a new concept for a lot of people. How do you get real-world data in there? Oracles really don't provide a standard way for you to have attestation of that data. Cryptlets provides that to you by default. But Cryptlets does more than that. It's more than secure data, it's also secure execution. How can you enlist complex execution tasks off the chain while keeping that integrated developer and business and operational experience, and also create a marketplace for developers in this audience? You might come up with Cryptlet ideas to create a Cryptlet library that you can put in the marketplace and sell to a specific industry. They can be vertical and horizontal in nature. So there's a lot of infrastructure here that we're building to wire this up. We are making, our goal is for the Cryptlet fabric, that's what we're calling it, or the blockchain Cryptlet fabric, to be easily consumed by developers. So you'll be simply being able to make or discover Cryptlets out in the marketplace, references to them, declaratively state what you want to do in code with those Cryptlets, and have the infrastructure just work. And you be able to focus on getting your code to run and accomplish the business goals that you're trying to build. So the goal here, and this diagram is oversimplified greatly. Down on the right-hand side, we have a node. This is the EVM that has this thing called a crypto delegate, which handles the delegation of calls out to the Cryptlets. Cryptlets manage the entire security envelope. So we're essentially extending the trust envelope for not just data, but execution, which gives you lots of interesting things that you can do. So let's talk about some of the use cases. So the most common one people think about are for oracles. And this is where you're going to want your smart contract to do something based on an event. So it's a traditional pub-sub type model where you're going to go and say, hey, I need to, I want to have this Cryptlet do something for me. In this case, I'm down here in the code, which you can't read, but we have a little attribute here where we're subscribing to an event saying, wake me up at 4 o'clock Eastern Standard Time if the markets were open that day, and if they were open, give me the LIBOR rate and the price of gold. And what's going to happen is that subscription goes up, the Cryptlet gets the rules for waking up that smart contract and says, okay, I'll wake you up when it's 4 o'clock. If the markets are open, the price of gold and the LIBOR rate. So the Cryptlet sits there and runs, and it checks, and when the event conditions are correct, it fires the event. The event payload includes an attested value of the LIBOR rate and the price of gold. Now, you don't just get the values, but you also get a three-way attestation. You get the signature of the Cryptlet itself, you get the signature of the enclave, which I'll talk about here in a moment, and also the attested hoster. So you have this trust envelope, which is actually sealed, and you can record all of that in the smart contract for audit purposes. So that one's the easiest one to kind of get your head around. The second one's a little bit more advanced, and it's really taking this three-tiered architecture to a little bit further extent. This is what we call control, and this is where you're using your smart contract more as a traditional database. So your smart contract, you're declaring essentially the data that you're keeping track of, and then the stored procedures, if you will, for updating that data. So you're not writing CRUD functions, but you're doing the insert or the create and the read functions for the data in the smart contract. You are then enlisting control surrogation, so full surrogation of your logic out to the Cryptlet itself. So the Cryptlet can run off-chain, and you can scale it vertically. So it won't run on every single node. You can have it run on at least one or a couple of nodes. And this usually becomes attractive to consortium networks where you have, for example, a hedge fund and a bank entering into a financial trade that has to have greater performance. There might be an algorithm for pricing that needs to be kept secret. And that can be run in the Cryptlet itself off the chain, but still preserving the goodness of the distributed ledger. So when you bring these into practice, these two use cases fall into these types of Cryptlets. So utility Cryptlets, here's an example. Again, I doubt you can read this code, but this is a smart contract here. I'm marked in yellow where the event subscription happens. This is the exact same description I used for event, where you're subscribing to an event for a specific time, if the market's open, for a certain rate, to give you a rate and a price of a commodity in this case. And what happens is you simply request that the crypto delegate wires up the secure connections between the smart contract and the Cryptlet itself. So it's just like a secure reference. So a developer at design time will reference the Cryptlet they want to trust. The signatures are recorded, and it wires up that, and the crypto delegate can also check and enforce that the messages only come from that Cryptlet. So it wakes up the smart contract to go ahead and execute the code. And you see the code body itself down here. The Solidity code has all the calculations that we're performing. So that's going to run on every single node once that has been seeded. The contract Cryptlet is actually deployed. In this case, we're using the deployment mechanism to actually create the surrogate for the smart contract in the cloud. So it goes through the crypto delegate, and it goes out and creates the contract Cryptlet. The contract Cryptlet does all of the market watching, all of the logic and execution until it's ready to store its state, in which it records the state down to the smart contract itself. Now here's where the real value is. I was like, hey, I can write this on my own. I don't really need. Why would I use Azure to do this? Well, the advances in silicon and the hardware security, namely Intel's SGX, provides the capability for you to create secure enclaves. So an enclave, if you're not familiar with what SGX does, is it's an area of on the chip itself that's in complete isolation, where you can run code and have data run where it's tamper resistant and tamper proof. So you can't poke into it, you can't step on a memory address space to go out and corrupt or potentially interrupt the execution of something. So this enclave provides a secure container, and then it provides full attestation level at the CPU level that this was actually built in the enclave and run in an enclave. Now, when you're starting to build solutions like this and you want to get scale and you want to have security and attestation, and you're trying to land that big contract with a bank or somebody that wants to make sure that your security is rock solid, if you can make guarantees that your code is running in a secure, isolated container in the cloud, full attestation in silicon and recorded into the blockchain, it gives that level of security that really you can't get anywhere else at scale, because you're going to be able to deploy this in Azure, and Azure's been deployed in over 30 some odd regions around the world. There's several here in China, so you'll be able to deploy these across the application fabric within Azure. Now we're going to be delivering these enclaves in what we call a Cryptlet container. Cryptlet container is essentially an enclave-based container wrapper where you inject Cryptlets in there. The Cryptlets are written in the language that you want to target. So in this case, the first one will be the .NET Core CLR. That's the open source .NET version. Cryptlet container. Then you can write it in C#. Some of you might have read about fstar. So you have lots of language choices there. Also in the JVM, which is also very popular in the enterprise. And then the EVM itself, moving into an enclave. So this type of scale, rolling out this type of innovation in these massive data centers where you have on-demand secure execution provides you with these 5 benefits. So a hyperscale cloud, secure execution in enclaves, on demand, worldwide. Same thing for data and data providers. So you can start to mix and match. You might have a great data provider for some sort of data service, and you want to create Cryptlet libraries that you can put into the marketplace and make discoverable. You have scalability and flexibility options now that you don't have, and you have them at scale. So you'll have the developer tools, you have the ecosystem, you have the marketplace, and the cloud where you can go out and not only scale your solution, but also scale your execution off the blockchain if you need to. So you have a lot more choices. Very developer friendly, so you'll see lots of tool integration, and an ecosystem for ISVs to start building solutions. And a standard way. We're not, you get a common way to do something and it becomes fairly readily accessible around the world and something that becomes attractive to larger enterprises. So that has, if you're curious about that, today we released the white paper for Cryptlets in Depth to go out. This again is, thank you. It is out. It almost didn't get out because of the network here. I had to push it up to GitHub this morning, and I thought it was going to choke on it. It is 26 pages long, but it has some fairly good detail about Cryptlets. But that is coming. We're building that now. So you're not going to be able to go out and start writing Cryptlets tomorrow or today. I know some of you, I watch presentations, you start, before the presentation is over, I see people downloading code and starting to try things out. You can't do that yet, but you can read the spec so you can start planning for it and thinking about new solutions, new business opportunities for you. What you can do today, and I'm proud to announce, is Bletchley V1. And this is our Ethereum consortium blockchain network. Ethereum is the first, again, in the marketplace with and this is anywhere from 2 to hundreds of nodes by answering a couple of simple questions. So when we went down this and we started to say, okay, what does the consortium network look like for Ethereum? So we do this a lot. We have a lot of companies come to us and say, hey, we want to start a consortium. How do we set these up? It's not the private Ethereum network's easy. You install a node and you stand it up. So we had to go through and figure out, what are the requirements? So this list of requirements we saw consistently takes about 3 weeks to get right. That's everything from network configuration, isolation, where do you want to put your miners, where do you want to put your transaction nodes, how do you automate this so it's very fast and easy to do. So we took this 3-week process and we got it down. We eliminated all but 2 of the steps. Okay, you still have to read up on how to do Ethereum. Once you deploy an Ethereum consortium network, you still have to understand, how to write a smart contract. We did all this, and we got it down to 5 minutes, answering 8 simple questions. And you can deploy, again, as little as 2 to hundreds of nodes on a private Ethereum consortium network, which is staggering. We thought we did a great job going in from 2 days to 20 minutes for a single Ethereum node to this massive network that you can deploy in very little time. So, thank you. Thank you. Thanks, Sid, Isaac. Those guys are out here. They were up at 3 o'clock in the morning making sure that this. So guys can find this. The link is out on Azure right now. You can find the blog post. It'll take you right there. This is real quickly what it looks like. It creates multiple subnets, and it puts each consortium member in its own separate subnet. For example, the miners are on their own subnet. You can't reach the miners from the internet. You can only reach the miners from the transaction nodes, and the transaction nodes are on a separate subnet as well. So we put quite a bit of thought into this. It also stands up a portal, seeds the network with Ether, and you can go out and immediately go to the portal. We are allow you to really quickly get up to speed and show your network running, something our customers have really wanted to see. So I want to leave you with a little bit of a roadmap where we're at. So earlier this summer, we released Dev Test Labs for blockchain as a service in general availability. So around the world, you can go out and create a Dev Test Lab. If you haven't done that, it's very easy. That's where you can see all the, not just Ethereum, but all the other blockchains that you want to build. Bletchley V1 is Ethereum only right now. First on Ethereum, first on Azure for consortium network. Kinakuda is our security work group. Some of you have probably seen that community. We'll be publishing more information about fstar, the tools for formal verification, to the community to help facilitate and move that effort forward through Microsoft Research. And then sometime in the near future, in a distant galaxy far, far away, we'll have releasing the Bletchley SDK. Actually, it shouldn't be that far, and it should be in this galaxy. So with that, I'd like to thank everyone for your time, and enjoy the rest of the show.
Thank you, Marley Gray.